Good morning, everyone. Myself, Lavanya Mariyappan, and I'm a recent biomedical engineering graduate from the University of Dundee. Uh, Today, I'm presenting my work, which titled under Inhaler System and Methods for Detecting Valid Usage of the Inhaler System. This work mainly focus on a reliability of how the smart inhaler by approximately identifying whether the inhaler is properly used by the patients or not. So, moving to the other slide as an introduction, as we all know, inhaler is one of the most common treatment for the respiratory conditions like asthma and chronic obstructive pulmonary diseases. However, inhaler technique is very important for the effective drug delivery. Uh, Unfortunately, there is a significant number of patients misuses the inhaler due to their unintentionally or due to the poor technique use. So to address this gap, we mainly focused on developing the inhalers by incorporating few other sensors into that. Uh, the problem is the current inhaler which detects the valid usage events by based on the single sensing approach. I feel like single sensing approach is very insufficient. Why? Because this results in incorrect valid usage as a valid usage because it tells you either even the activation inhalation without inhalation or the users misuses the device which still results in the valid usage count. That's uh, very inappropriate for the even for the physicians to give proper treatment for the asthma peoples or the respiratory problem peoples. So our solution was we approached the multi-sensing approach just by incorporating the few more sensors into the inhaler body, which is the temperature sensor, pressure sensor, and the proximity sensor. There, I'll just come up with what are the role for their sensors. The thing is, valid inhaler usage produces a combination of multiple signals. This includes the pressure sensor validates the negative pressure while during the inhalation, and while coming to the temperature sensor, which also validates the oral airflow combinations. You know, as obviously the oral temperature is different from the ambient temperature, so that way we can justify whether they actually puff the medication into their lung or no. And along with that, there is one more proximity sensor which really validates the mouth engagement, whether they actually place the inhaler into the mouth and puff. So this all combined together, only when these signals occurs together is the usage even classified as valid. Otherwise, it's invalid. Um, this is our proposed device along with the mechanical and the sensing architecture. uh, Before with this sensor there is a one more important thing. We have to protect the sensors bodies. For that there is a hydrophobic membrane which we use to protect the sensors, to uh, to avoid any moisture or any medication particles which destroy the sensors working principles. uh, to improve their long term reliability, we incorporate the hydrophobic membrane into that. Also, this is the system architecture of the smart inhaler showing sensor integration and communication pathways. So how this sensors placed in the inhaler body and all this data passing through the processing unit, like where the actual validation works, and which tells you whether the event is valid or invalid. And even the data can be stored and can pass through the tele. It also useful for the telemedicines, which wherever the physicians can give the proper instructions and proper medications for the people who having these problems. So it's all about, nowadays the world is turning to the digital health platform, so this way is more up good thing for the uh, respiratory problem peoples. and this is how the actual logic flow chart goes on. It tells you it first the temperature ambient, it deducts the ambient temperature and the oral temperature. That way, if it is greater or equal to 1.5 degrees Celsius, then the event considered into passing to the pressure sensor, and the pressure sensor passing to the proximity sensors. So all over this will gives you the event as a valid yes or no the things. So that way, you can know the patients will actually inhale the medications, and the drug delivery is got efficient in that way. And more importantly, while coming to the intellectual property, I would like to tell you the system architecture and the deduction methodology are aligned with the published patent application filed in 2025 by me, which is under now currently under the examination process. So this supports the novelty and the translational potential of the work. I'm happy to share this with you all, guys. And after this, there is when coming to the future clinical validation, I would say, as I already informed, the digital all over the world is changing to the digital health platform. So this evaluation, I would say, it's turnover for the world. So observational study in asthma or the chronic obstructive pulmonary disorder patients using the smart inhaler in a real world settings, comparison of device recorded adherence with the pharmacy relief data and the clinical review, analysis of relationship between the objective adherence, symptom control, and exabrasional frequencies, supports translational evidence and regulatory grade evaluations. So these are all what we thinking about the future gonna turn by these innovations. And what we expected the results are more reliable adherence data than the actual counting. The current smart inhaler only have the activation counting, or either it's only have the single sensing approaches. So that way we introduced our multi-sensing approach for the better support for the clinicians and the digital health platforms in optimizing therapy. Architecture designed for integration with mobile app and cloud-based monitoring, more useful for the telecommunications. Clear testable threshold, which suitable for the formal verifications and validation protocols. So further, the step is we have to develop the actual prototype device of this. So we are getting into that work, and this are all the top five reference we refer to develop this work. And that's all. Thank you for everyone for giving this opportunity. I'm now happy to answer any questions follow up.